Hi guys, so today we are talking about observing mechanisms. Oops, sorry, as I'm dragging things around. All right, so today we are talking about observing mechanisms. And for the most part, most of this is going to be new for many of you. So basically, a mechanism is any device that transmits movements so that the output is different than the input. Now, what this means is basically that if your output and input are different strengths or different directions, that can be a mechanism. So mechanisms generally do one of three things. They change direction of the motion or the force, they change the speed and torque, or they change the type of movement. The output of any machine or robot has got to be motion or force in some way. So if you look over here at the drill press is actually doing two motions. It's spinning the drill bit around, and it's also lowering that drill bit directly downwards through the material that it's going through. So you've got rotary motion on the spin and linear motion for the downward press of the drill press through the material. So speed will be in some sort of a range. Usually you adjust the speed of a drill press with a set of pulleys, which is how the mechanism part comes in, because that would be a mechanism up here in the top of your drill press. To adjust the speed and the torque of the whole mechanism. So, move that. So, when you're riding a multi-speed bicycle, this might be a better example for many of you. When you're riding a bicycle up a hill, what do? You probably shift gears in order to get more power with the same amount of effort. Sometimes when a vehicle's going up a super steep hill, it'll do something similar called downshifting, or they'll engage the four-wheel drive in order for the vehicle to have more torque to be able to get up that very steep hill. This need to change speed and torque is a problem that's super common in machine tools, robots, automobiles, airplanes, all sorts of different things. In this activity, we're going to look at different ways to adjust and look at speed and torque. So, first off, let's do a quick check for understanding. What was a mechanism? Move me over here. A mechanism is all the way back here. Mechanism, that was a device that transmits movement so that the input and output are different. So then what was the output of any mechanism? Output of any mechanism would be, that's right, motion or force in some form. So that got us over to here, gear trains. Gear trains are super interesting, and we spend a lot of time on gear trains. So a gear train is basically a mechanism that's used for transmitting motion and torque. When gears are meshed, they form a gear train. So notice that the teeth here are touching each other. That means that they are meshed. So as this first gear turns, it causes a downward force here on these teeth, which basically catches these, forcing them in the opposite direction. So as this turns that way, this one goes the opposite way. So meshed gears are always turning in opposite directions. Gear ratios compare a driven gear to a drive gear. If the input or driver gear completes one revolution for every two completed by the output or driven gear, this means that that output gear is going just a little bit faster than the input gear. And you can kind of see that here in the example that as the driver gear spins, it's going to push the driven gear, and that driven gear goes just a bit faster than the drive gear. There we go. Okay, so drive gears are input, driven gears are output. Yes, this is common terminology, and in our curriculum, they're pretty much used interchangeably, driver and driven, input and output. So gear ratios are basically done for us by counting teeth. So you count the teeth on the gear. And I'll tell you right now that this big gear has 32 teeth on it. And that the smaller one over here has 22 or so. 22. There we go. So the way you would figure out the gear ratio is you take the output and divide it by the input, or output over input. So in that case, because I don't expect you to like simplify these, so the driver has 32 and the driven has 22. So that means the output is 22 and the input is 32, which makes it 22 to 32 or 22 to 32 this way, or you could write it like a fraction and put your 22 here over your 32. Now, here's the deal. I would not expect you to simplify this because that's not what we're here to do. We're just looking at the gear ratios themselves. So what's a gear train? Well, for that, we got to go back here to what's a gear train. It's a mechanism used for transmitting rotary motion and torque over a distance. What's a gear ratio? Also back over here. It is a comparison between the driven and the drive gear. Three purposes of mechanisms. All the way back to the first page, change the direction of the motion, change the speed or the torque, change the type of movement. Those are the three purposes of any mechanism. So, a force is a push or pull in a straight line. Now, that could be up, that could be down, it could be across. But think about just pushing a box across a surface. That's a push. That's a force. A force in a circular direction is torque. So think about spinning the box on the table. That would be torque. Gears turn in a circular direction, making an inverse relationship. Inverse means reversed. Basically, inverse means one goes up, the other goes down, between torque and speed in gearing. A 10-speed bicycle tends to have like 10-speed gear selections. When you pedal up a hill, you use the gear train that gives you more torque because you want more turning force to go up the hill. In doing so, you end up with less speed and slow down. When you pedal on flat land, you change the gears so that you get more speed, but in doing so, you get less torque. So when pedaling up a hill, we trade off speed for torque. In other words, these are opposite things. So when speed goes up, torque goes down. When speed goes down, torque goes up. When torque goes up, speed goes down. When torque goes down, speed goes up. They are always opposite of each other. If one's going up, the other's going down, and reversed every time. So, when do you want which one? When do you want more torque and when do you want more speed? So look at the image here, and the first thing we're going to do is we're going to label the drive and driven gears. This, believe it or not, is supposed to be a pedal, right? It doesn't really look like a pedal to me, but that's okay. That's what it's supposed to do. So that should be the input sprocket there because that's the pedal. Meaning this one over here is also the input sprocket because the pedal's there, making the other sprocket the output, which makes this one also the output. So now we have our gears labeled. We have our drive gear, which is our input, and our driven gear, which is our output. The gear train and which gear train provides more torque. So think about it. If I'm spinning this guy around once, this one's going to turn more than once. So that means it's got to go slightly faster. If I turn this one once, this one doesn't even go all the way around. That's going to give me a slower speed, which means it's going to have more torque. So B is going to give you more torque. So the one that gives you more speed would be A. Which one do you want when going up a hill? Well, obviously you want more power, you want more speed or more torque and less speed, so you're going to want B when going up a hill. What's the relationship between torque and speed in gear trains? More torque means less what? Whoops. Let's see if I can, oh, writing on my computer is really awful. Sorry. So, whoops, there we go. So if I want more torque, I get less, I'm just going to use an arrow, speed. There we go. Less speed. If I want more speed, then I'm going to have less torque by definition, because I'll have less torque because it's going to be going faster. So